To complete our study of the topic of motion, we have to say some things about acceleration. If your position is changing, you have velocity, and you can write that in the notes. And we've already talked about velocity. One way to write it is this: velocity is your change in position. We can call that delta x over the time that it took to change, delta x over delta t. Or you could write v is x over t. Or the equation we've used the most is the average speed is distance over time. These are all the same thing conceptually. Velocity or speed is distance divided by the time, and velocity, of course, would indicate the direction as well. So if your position is changing, you have velocity. That's what it means to be moving. Your position is changing and you have velocity. If your velocity is changing, then you have acceleration. If your velocity is changing, you have acceleration. And you could write the equation for acceleration like this. Acceleration is your change in velocity divided by the time that it took for your velocity to change. And there's another way we could write that equation. We could say the acceleration is equal to the final velocity minus the initial velocity divided by the time. And you should recognize that this change in velocity is the same thing as the final velocity minus the initial velocity. If you go from 10 miles per hour to 15 miles per hour, your change in velocity, you changed your velocity by 5 miles per hour, and that 5 is the same as the 15 minus the 10. The change in velocity is always the final minus the initial. And in fact, this is the definition of acceleration, change in velocity. So you can write that in your notes too. Acceleration can be defined very simply as change in velocity. Change in velocity. Now it's important to note that any change in velocity is acceleration. If we define acceleration as change in velocity, then any change in velocity is acceleration. And this would include speeding up or slowing down or changing direction. All three of those would be acceleration. Now, this one might throw you here. Slowing down, we often refer to that as deceleration, and that's fine too, that's accurate. But according to this definition, if acceleration is any change in velocity, then slowing down, that would be a change in velocity. So that would be an acceleration. And mathematically, that would end up being a negative acceleration. But all three of these would be acceleration under this definition. So the term acceleration in everyday use simply means speeding up or getting faster. But in the precise language of physics, acceleration is any change in velocity. And then also a change in direction is an acceleration as well. Remember we said that velocity is a vector. So velocity has direction. So if you change your direction, even if you stay moving at the same speed, if you change your direction, then you've changed your velocity. In other words, say a little airplane is flying along here, and here are the wings and the propeller. Say it's flying this way to the north, and then say it turns. So now it's flying east. Well, even if it's moving at the same speed, say it's moving 100 miles an hour. 100 miles an hour to the north is a different thing than 100 miles an hour to the east. So that's a change in the velocity. But because the velocity tells us how fast it's moving and in what direction. And so that would be called an acceleration. Now, in all three of these cases, the acceleration is something that you can feel. When you're sitting in there, when you're sitting in a car and the driver steps on the gas, you feel the pull. You feel your own inertia tending to hold you back, and that car pulls you forward, and it's sometimes called G-force because it feels very similar to the pull of gravity. You feel that sensation if that car is accelerating forward. And when the driver hits the brakes, you feel the same thing in the opposite direction. You feel thrown or pulled backward. You feel the pull from the acceleration. And you feel that also when the car goes through a turn. And I'm sure you've experienced that. When the car goes through a turn, you feel thrown to one side or another. When the car speeds up or slows down, you feel thrown backward or forward, and when it takes a turn left or right, you feel thrown to one side or another. In all of those cases, the feeling is the same. So you can feel the acceleration, and you feel that same thing in all three of these cases, maybe in a different direction, but it's the same feeling, what we sometimes call G-force. You don't feel that if you're just moving at a steady speed. You can't detect any sensation of motion if you're just moving at a steady speed. You could be sitting in your desk, sitting perfectly still, or you could be sitting in a car going down the road at 50 miles an hour, or you could be sitting in an airplane flying along at 500 miles an hour. In all three cases, you wouldn't be able to feel the speed. In fact, things would seem pretty normal. You could pour yourself a glass of water, for example. Sitting at your desk, you could pour yourself a glass of water. Or driving down the road at 50 miles an hour, you can pour yourself a glass of water. Or if you're sitting on an aircraft moving at 500 miles an hour, you could pour yourself a glass of water, and everything's fine. The fact that you pour the water out of the glass in an aircraft moving at 500 miles an hour doesn't mean that the water gets left behind toward the back of the plane at 500 miles an hour relative to the plane. That doesn't happen because it's all moving together at a steady speed. It's the acceleration that messes you up. If you've got a big soft drink and you're sitting there in the car and you take a sip of your soft drink, and right as you take the sip, the driver hits the gas. Well, the soft drink tilts back and sloshes all over your face. It's the acceleration that causes the problem. Or if you're trying to pour yourself a glass of water in the car and the driver hits the brakes, that's going to probably cause a spill as well. And a turn also will do the same thing. That will cause that G-force, and it would be very difficult to pour yourself a glass of water if the driver is turning the car left and right. So the point here is the acceleration is something that you can feel. You can sense it. You can detect a change in the velocity. And hopefully that helps convince you that all three of these things are really conceptually in the same category, because you can feel all three of those things and they all feel very similar, and you've probably experienced that at various times as well. Speeding up, slowing down, or changing direction just in a car, as we've all experienced, all feels the same. The same kind of sensation, the same kind of pull in all three of those situations. So I go into all of that just to try to convince you that all three of those things are in fact acceleration, and they all do belong in the same category as acceleration.